Alright, this video is in response to the one question that was on the discussion board about photoelectron spectroscopy, or PES. It was, how does the kinetic energy allow us to calculate the ionization energy? So, just to recap, the way it works is that we have some source of energy, of light, whether it's some force of electromagnetic something, whether it's UV or X-rays, being fired at a sample. And each one of those, whatever is being fired, those photons have an energy. So this HV right here, this actually refers to the amount of energy of that photon. So energy equals HV. And that's, again, of the photon. Okay, so usually UV or X-rays. And so just to kind of clarify something, H is a constant called Planck's constant. And Planck's constant is equal to 6 start with the C. Planck's constant is 6.626 times 10 to the negative 34th. V refers to the frequency of the waves of the photons. So on this picture to the right here, when we're looking at photons, they come in waves. Okay, the longer the wavelength from crest to crest, the shorter the frequency is. The lower the frequency is, the less often it happens. So the shorter the wavelength, the higher the frequency, the more often it happens in a given time. Okay, so that's what the V is. So when we're using PES, we know what the energy of this photon source is. Okay. What we don't know, what we're trying to figure out, is the binding energy, or that ionization energy. So this one we know based on what rays, whether X-ray or UV rays, we're firing at the sample. And then this is the kinetic energy of the electron. Kinetic energy is something we'll go more in detail with in physics, but it is Ke equals 1/2 mv squared, where m is the mass and v is the velocity. So once we have the sample of the electrons, we can analyze the energy of those electrons by looking at the velocity of the electrons, as well as, of course, the mass of the electrons. We can calculate the kinetic energy of the electrons. So whatever energy difference we have, that's the energy that was required to break that binding energy. That's the ionization energy. So the lower the ionization energy, the faster the kinetic energy.